So last video we have seen one-way ANOVA. Now we are going to see a problem in two-way ANOVA. Look at this. To study the performance of 3 detergents and 3 different water temperatures. So we are going to compare the performance of detergents as well as temperature. The following whiteness reading were obtained with special designed equipment. So now by using cold water, warm water, hot water, 3 types of water. So I have to find the difference between this and this and this. So it is row wise also I am going to find the difference, as well as detergent A, detergent B, detergent C, how they are unique or they are different from each other. So this is column wise also I am going to find. So we have a two-way ANOVA. So normally we have in the previous one-way ANOVA fertilizer 1, fertilizer 2, fertilizer 3. So we are finding the difference between only these 3 fertilizers. So we have the column wise component, that is SSC and then MSC and all those things, and we got only 1 F ratio. Now we will get 2 F ratio, one for column wise component and one for row wise component, that is SSR. Total sum of squares of rows and sum of squares of columns. Now whenever they have given a question whether it's one way or two way, we can reduce the values. If you see here, the sum of squares means these values are too huge. So we will take a deviation factor. It is up to your wish, that is which is closer to all the values. Now if you notice, all the values are most of this 40, 40, 40, 40, 40. So now out of these values, this is 39 also close to 40. So 3, 4, 5, 6 values are close to 40. So I'm going to choose the deviation factor as 40. What I'm going to do is I'm going to subtract all the values from 40. So the first one is 47 minus 40. So I'll write it as 7. And the second one is 45 minus 40. So I'll write this as 5. And the third one is 50 minus 40. And then I'll write this as 10. And if you add all these values, 10 plus 5, 15, 15 plus 7, that is 22. So this is total T. Same way we are going to add, subtract the values, that is 39 minus 40, which is minus 1, write it along with the sign, 42 minus 40, which is 2, 52 minus 40, which is 12, and the total of 12 to 14, 14 minus 1, 13. So please be careful with the negative values also. And then the last one, 44 minus 40, 4. And we have here 36 minus 40. So now 36 minus 40 will become minus 4. And the last one is 48 minus 40, which is 8. So plus 4 and minus 4, if you add, it will become 0. And then 0 plus 8, 8. So now you are going to add all these things, which is 43, which is the grand total or the total T. Because for the correction factor, we will be using this formula. And now you have to add, like in the previous one-way ANOVA, we will add only column wise. Now we will add row wise as well as column wise. So now 7 minus 1 plus 4. So which is nothing but 7 plus 3, 10. We are going to add column wise also. So we are going to add 5, 2 and then minus 4. If you add all the 3, we will get 3. And then again you are adding 10 plus 12 plus 8, which is nothing but 30. So you just add all the 3, 10 plus 3 plus 30, you will get 43. So now we are going to find the correction factor. So if you add row wise and column wise also, this value is going to be the same. So to find the correction factor, same as the formula that we have used in one-way ANOVA, T square by N, which is 43 whole square by how many values are given? So only 3 rows and 3 columns. So total 9 values are given. So 43 the whole square by 9, which is 205.44. So this is your correction factor. Step 1 is over. Step 1, what we are going to do? We are just using the deviation. If you want, you can find out as it is by squaring it and adding it, but it will be too huge. That is why we are using the deviation factor. So now step 2 is you have to find SSC. SSC is nothing but the total that we have got here, right? That is 10 square, this total. 10 square by how many values are there in each column? So if you see each column, we have 3 values. So this is row wise also 3 values column. For example, if we have one more value in this, so you will say 4. Now we have 47, 39, 44. Only 3 values here. So 10 square by 3. Then next one is 3 square by 3 plus 30 square by 3. So these minus correction factor. So correction factor, which is nothing but 205. 3 we got it from this total. 30 we got it from this total. So your SSC happens to be 130.89. So SSR means the total in the row. The first row total was 22. So 22 the whole square by 3. Each row also we had 3 values. So 13 the whole square by 3 plus 8 square by 3. All these things minus correction factor. Your formula is similar. So SSC we used all these column total. So if you notice, this is the first column total, second column total, third column total. That is what we have used. So for SSR, first row total is 22, second row total is 23, third row total is 8. So I have written this minus correction factor. So now your SSR is nothing but, if after simplification, you will get 33.55. Please check the values, and first you have to add all the values which is there inside the bracket, and then only you have to subtract it from the correction factor. Now we are going to find SST. So SST is total sum of squares. Already in one way ANOVA we have done it. So what we are going to do, we are going to square all the values which is there in your, that is 7 square plus 5 square plus 10 square. Don't square the total. So 7, 5, 10. And then minus 1, 2, 12. And then 4, minus 4, 8. So all these things we are going to square it and then minus correction factor. So I will write it 7 square. You can scroll up while writing notes and then you can check 4 square, 5 square, 2 square, minus 4 the whole square. So all values will be positive because we are squaring, and then all these values we have to add minus your correction factor. What is your correction factor? Just now you have calculated. Your correction factor is 205.44. So when you calculate this, you will get SST as 213.56. Now SSC is over. You have to calculate SSE. SSC we have calculated. Always this in one way ANOVA we will write SST minus only one SSC, because one way ANOVA we will compare only with respect to column. Now we will compare with respect to row also. So your SST is, let me write in the next line. Just now we calculated this one, 213.56 minus, open the bracket, this is 130.89 and plus 33.55, which gives you 49.12. So your SSC you've got. Now we have to form the tabular column, and the final table is similar to one way ANOVA. In one way ANOVA we had only between the samples, that is between the column, correct? So now in two way ANOVA it is between the rows also. So when we write sum of squares, between the columns or samples is SSC, which is nothing but our calculated value. SSC we have calculated here 130.89. We are just going to write down the values, 130.89, and between this row is SSR, which is 33.55. This we have calculated, and your is residual or the error, that is SSC, we are adding it this, which is nothing but 49.12. So now we have one more value which is added to it because of the two-way ANOVA, one for the column, one for the row. So now degrees of freedom, first always what we did, number of columns minus 1. Here we have 3 columns minus 1, which is 2. So this is your V1. Okay, and then this you take it as VR. So this is also 3 rows minus 1. So number of rows minus 1. This is R minus 1. This formula is C minus 1. Some questions you may don't have equal number of rows and columns. Here rows and columns are equal. So this is 2. And now your V2 is here. Multiplication of this previous two values. What is the first value we got? 2. Second value we got 2. So this is 4. Okay. So now this is also over the degree of freedom. Now mean sum of squares. So always what is the formula? MSC is SSC by V1. So that is 130.89 divided by V1 is 2. So this is your value, and this you can write it as VC column. So it is even more easier. It won't be confusing for you. So 65.45. So this is 65.45. And then this is MSR is nothing but SSR by VR. That is 33.5 by 2, which is nothing but 16.78. And your last value, which is MSE, which is nothing but SSE by this V. So this is nothing but 12.28. That is 49.12 divided by 4. Now your tabular column is ready. We have our F ratio at last. So I should have drawn the table here. Finally, when you have F ratio, your first F ratio is going to be between the values MSC by MSE, and so I have calculated this also. MSC by MSE is your first ratio, which is 65.45. Here is 65.45 divided by 12.28, which is 5.3. This is your first F ratio that you got between the columns. Same way between the rows, if you have to find the F ratio, this is MSR. So your MSR is here 16.78 divided by 12.28, which is 1.37. This is the F ratio that you have to compare between the rows. Now for the corresponding degrees of freedom, we are going to compare it with the table values, that is 5.3 and 1.37. So now we are going to check the values. The first value is 5.3. So 5.3 is less than 6.94. So what we are doing? We are accepting the null hypothesis. We didn't frame the null hypothesis yet. So your null hypothesis, your first, this one is no significant difference between detergents. So it's like almost all detergents are equal. So we are accepting the null hypothesis. So there is no significant difference between the performance of 3 detergents. And then if row wise we calculated 1.37. This is for different water temperatures. And remember degrees of freedom V1, V2. So how you have to calculate? For the fourth row, always V2 will be here, V1 will be there. So 1, 2, 3, fourth row, second column 1, 2. This value for 5% will be 6.94 in your tabular column. So we are checking, and this 1.37 also is less than 6.94. So we are accepting the other hypothesis also. There are two hypotheses, no significant difference between the water temperature. So we conclude that we are accepting the null hypothesis. Thank you.